Alright, so I think I can make it through this video. This is Basics 12 practice. I'll do the ACT and some bonus and stuff first. How many distinct prime factors are there of 130? A lot of kids are missing this problem. It's not a hard problem. You just break it down to its factors. So I know 130 is twice as 65. You know, 65 ends in a 5, so it's probably divisible by 5. And it turns out it is. It's 5 times, I think, 13. Yeah. And there's your factors. Of course, you've got the 1 and the 130. But anyways, those don't matter. These are both all 3 prime numbers. 2 is prime, 5 is prime, 13 is prime. So 3 primes, 3 distinct primes. ACT 2 is talking about a right triangle. I did notice that some of y'all don't know how to draw a right triangle. It says angle C is 90. From there, it doesn't really matter which one's A and B. When I taught geometry, I always told kids to go clockwise. Put A in the first left-hand corner and go around like clock. But B is 30 degrees, which means there's 60 degrees left over here for angle A, because there's 180 degrees in the triangle. You're told that A to B is 32, and that B to C is 16 root 3. So what I would really like for you all to be able to do is I'd like you guys to memorize 30, 60, 90 theorem. That's what I'd like. 30, 60, 90. The hypotenuse is twice x. The short leg is x. And the long leg is x root 3. Now, you'll notice that here's your 30-degree angle, so this is supposed to correspond with an x. This is supposed to be x root 3, and this would be the twice x piece. Well, what's 32 twice of? It's twice of 16. Missing side length is 16. And if you don't want to do that, then you're going to have to do Pythagorean theorem. You're going to have to say this 16 root of 3 squared plus some unknown, we'll just call it x squared, is 32 squared. And those numbers are a little too big to be doing by hand. So I wouldn't go that route, but you can if you want to. All right, ACT 3, find the value of k such that the determinant of this matrix is 12. The determinant of a 2 by 2 matrix containing the elements A, B, C, and D is defined mathematically to be AD minus CB. So that's what I'm going to do. I'm going to multiply those two pieces together. I'm going to take away the result of 10 times the negative 3, and it's going to equal 12 because the value was already known. So negative 6k plus 30 is 12. If I subtract 30, I think I'm at negative 18. And if negative 6k is negative 18, then k has a value of 3. All right. I'll do some bonuses. I'm getting short of breath. I need a second. Feel great. All right, bonus 1. Given f of x is 2x squared minus 3x plus 3, find f of x plus h. So there's that funky function notation that y'all just love. But basically, anywhere you see an x, you become x plus h. It's not hard. I don't know why a lot of kids won't do it. I guess, the truth is the only kids that actually need to understand this are the ones that take calculus. So you got to move pretty far up in the math world to actually get to the point where you begin to understand why you need this. It's called instantaneous rate of change when you do bonus 2. This is the first part of it. So I just plugged in x plus h for every x I saw. I wrote this one out twice because it was squared, and now I'm going to FOIL it. I'll get x squared plus 2xh because here's an hx, and here's another one, plus h squared. And then I'm going to clean it up. I'm going to distribute this too. So that's 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 3. And there are no like terms there, so that's what it's looked like. It's kind of ugly, if you would. I'm going to go ahead and jump down to bonus 2 since they're related. It's given the same function as bonus 1, find the difference quotient, which is also known as the instantaneous rate of change. I should end up something with along the lines of probably 4x minus 3 plus something. But that's a shortcut, which I'll teach you when you take calculus. I have no idea what the something is. Probably like take away 3h or something. Anyways, I already did this work. It was right there. 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 3. And I'm supposed to take away all of the original function. That's what it says. So make sure I use parentheses. It's all sitting over an h. There's going to be lots of cancellations. We have a 2x squared minus another 2x squared. That's gone. We have a negative 3x minus a negative 3x. That's gone. We have a 3 minus a 3. Gone. Gone. There's always 3 things, well, sorry, I guess 6 things that cancel out. Always. Now I'm sitting at 4xh plus 2h squared minus 3h, all sitting over an h. And all 3 pieces of the numerator contain an h, as does the denominator. So I divide out the common factor, which is h. And I'm going to rewrite it as 4x minus 3. I'm going to put this piece first, plus 2h. And that is the instantaneous rate of change for that function. Go ahead and stop this one.